Howdy folks, I'm going to go over just kind of the how to do problems in review number 4. The subjects here are area, net change, u-substitution, and average value. It also includes total distance traveled of an object, which is kind of a part of net change. The first page, they're all area problems, and they all basically ask, let's see, what is the area of the region in the first quadrant? What's the area of the region in the first quadrant? What's the area of the region enclosed by the graphs of? An area always requires you to do a definite integral of, you're going to have some function on the top and some function on the bottom of the region, and then we're going to subtract top minus bottom. And then you have some left, the farthest left x value all the way to the farthest right x value. Now oftentimes the left x value and the right x value are the intersections of the top function and the bottom function. So if you have something like this, see, you have the left bound over here, which is a left intersection, and the right bound over here, which is the right intersection. Now that's sometimes, and those are the ones that are usually easiest to do. However, you have to understand that sometimes the left bound might be a vertical line. The very first question says, what is the area of the region in the first quadrant, and this is the first quadrant, bounded by the graph of y equals 2 to the x power. Well, y to the 2 to the x power looks something like this. Y equals 2 to the x power and the line x equals 3. And here's the other thing. Sometimes the top function or the bottom function is a horizontal line. Okay? Now this graph, this region is in the first quadrant, bounded by y equals 2 to the x power and the line x equals 3. Now, a lot of people got confused with this question. They thought it was y equals 3. They thought it was a horizontal line at 3, but it's a vertical line. And we did this at the beginning of the school year. We talked about vertical lines, x equals, and horizontal lines, y equals. An x equals line is a vertical line at x equals 3. So if x equals 3 is here, here's the vertical line. And this region is the region. Once you have the region, you can see that the top function is 2 to the x power. But the bottom function is the y-axis. That's just y equals 0. So where people thought this problem was more difficult, it's actually less difficult because it only has one function that you have to deal with. Okay, and then, so that's top minus bottom, and the left x value of this region is the y-axis, which is x equals 0. And then the right bound x is x equals 3. So, it's not always an intersection point. It could be some vertical line, and that is those are the x value bounds. So in this case, you're going to integrate from 0 to 3, 2 to the x power minus 0, which means just 2 to the x power dx, and that gives you the area of the region. So what I recommend you do on all of these is graph it, and if it's got a vertical line x equals, you can't graph that. You just know that that is one of the limits of integration. It's either the lower limit of integration or it's the upper limit of integration. All right, moving on. We've got this thing where it gives you area, or it gives you a graph with areas. Now I'm not going to do the one that's in here, but I'm going to do one like it. Let's say that we have this graph that does this, okay? And we got something that says that the area in here is 4, the area in this region is 5, the area in this region is 3, the area in this region is 4, and maybe the area in this region right here is 2, okay? And basically it's asking, hey, what is the, and let's put some numbers on here, some x values, 0, let's say this is, but you don't have to have x values here, you might only have to know what the beginning and the end is, but let's put some on here anyways. X equals 2, let's say that this is x equals 6, this is x equals 9, if this is x equals 14, and this is x equals 16. So we might, and let's say that this is the function g of x. So let's say we want the definite integral from 0 to 6 of g of x, dx. Well, definite integrals are area. So if the area of this region is 4, okay, then and it's above the x-axis, so that's a positive 4 when we accumulate forward. Do you see this 5 here? The area of this region down here, this weird region, that's 5. But because it's below the x-axis, it's negative values. It's accumulating negative values. So this would, when it's a definite integral, definite integrals don't have to be positive. Area has to be positive, but not definite integrals. Definite integrals, they can accumulate negative values. So therefore, this would be accumulated as negative 5. So when we go from 0 up to 6, we're going to accumulate positive 4, then we're going to accumulate negative 5. And 4 minus 5 is negative 1. Okay? So that's how you, that would be how you accumulate. Now let's say that we were asked, well, what is the average value? Okay, average value problems are, and there's a bunch of them on this review. It's very simple. An average value between, let's say, 6 and 14. Okay? Average value from 6 to 14 is the definite integral from 6 to 14, and then you multiply it by a fraction that's 1 over 14 minus 6. So first we would do the definite integral from 6 to 14, so 6 to 14 above the x-axis and above the x-axis, so this is positive and this is positive. 3 plus 4 is 7, okay? And then we're going to divide that by 14 minus 6, well that's 8. So the definite integral is 7, but the average value is 7/8. Okay, so an average value, the formula for average value is 1 over b minus a times the definite integral from a to b of your function dx. So if we wanted to know the average value, if we wanted to know the average value of sine of 2x to the 5th on the interval from 3 to 10, we would do 1 over 10 minus 3 of the definite integral from 3 to 10 of sine of 2x to the 5th dx. And if you plugged this in your calculator, in a graphing calculator, it would give you the average value of sine of 2x to the 5th over the interval from 3 to 10. That's how you do an average value. All right, let's see here. On this question right here, question 13 is an optimization problem. So you would do it the same way you do an optimization problem. You would have all your critical values, which are the zeros of the derivative, and then you would identify all the output values. But in this case, like what if I wanted to do the, let's say that this is g prime of x, not g of x. But I wanted to know the maximum and minimum value on the interval from 0 to 16 of g of x, not g prime of x. So first I need the zeros of g prime of x. Well, the zeros of g prime of x are, and I need the endpoints. So I need 0 and 16, so I'll put 0 up here. And then I need 2, then I need 6 and 9, and then 14, and then 16, right? And then I need g of x. Well, g of x is the antiderivative of g prime of x. So all of these output values are going to be definite integrals. Okay? Now what if I knew, hang on a second. What if I knew that g of 0 was equal to 3? Okay? So at 0, g of x is 3. At 2, g of x is 3 plus whatever I accumulate from 0 to 2. Well, what am I going to accumulate with a definite integral? Basically what I'm saying here is that g of 2 is equal to whatever g of 0 is, which is 3, plus the definite integral from 0 to 2 of g prime of x. That is a net change problem. Net change says your ending value is your starting value plus the definite integral from the start to the end. From the start to the end of the rate of change. So, the definite integral of g prime of x from 0 to 2 is 4. We're accumulating 4. So 4 plus 3, g of 0 is 3, that's 7. Then, if we want to know what 6 is, well, we need the definite integral from 0 to 6. And then add it to the original starting value, g of 0. So 3 plus definite integral from 0 to 6 plus 4 minus 5. 3 plus 4 is 7, minus 5 is 2. So put a 2 there. So now for 9, we're going to start at 3, then we're going to go up 4, that's 7, minus 5 is 2, plus 3 is 5. Then for 14, we know once we get to 9 that the accumulated value is 5, and then we're just going to add 4 more. So that's 9. And then from 14 to 16, we're going to accumulate a negative 2. And so 9 goes down to 7. Okay? And now our absolute minimum is at 6, and our absolute, the absolute minimum is 2, so g of 6 equals 2 is the absolute minimum, and g of 14 equals 9 is the absolute maximum. Okay. All right. Let's see. All right, all net change problems. Water flows through a pipe. The rate at which water evaporates. All of these problems, all net change problems work the same way. You're given a rate of change in something, you're given a starting value in something, and they want to know the value of something at another time. So, value at another, well, not necessarily another time, it might be another x value, but let's say another, at another x or t. The value at another x or t is equal to the starting value plus the definite integral from start to the other time, starting or the later time. See, the thing is, sometimes it's an earlier time. Sometimes you're given the value at time 5, and they're asking for the value at time 2. So you're going to go from 5, the starting time, backwards to 2, another time, or another x or t. And then you're going to integrate the rate of change that they gave you in the problem, dx or dt. So water flows through a pipe into a container of water at the rate of P of t. That goes in here. So P of t, 23 times e to the 0.13 t plus 2 liters per hour. That goes in here. At time t equals 0, there are 5 liters. That's the starting time. So you're going to put a 0 here and a 5 here. How many liters are there in the container after 3 hours? You're going to put a 3 here. So it would be 5 plus the definite integral from 0 to 3 of P of T, which is the rate of change in water. And what's happening is this definite integral, 0 to 3, is accumulating all of the change that occurs from time 0 to time 3. And then adding that change onto what was already there. So if you have, 7 ounces of water in a cup, and you're pouring water in a cup slowly, let's say over 15 seconds, water is going to accumulate in the cup at the rate that you're pouring it. So the slower you pour it, the lower the rate, less water will accumulate. The faster the rate, more water will accumulate. And what you're doing is you're doing 7 ounces in the cup plus the amount of water that accumulates over the 15 seconds that you pour the water. That's a basic net change problem, and there are a bunch of them on this worksheet. 18 is a net change. It's a little more complicated, but it is a net change. All right, we've got here an object moves along the x-axis with initial position x of 0 equals 2. Starting position, 2. The velocity of the object, that's the rate of change in the position. Velocity goes here. The velocity of the object at time t greater than or equal to 0 is given by v of t equals sine of pi over 3t. The second question on here is, what is the position of the object at time 4? Okay, so at time 0, the position is 2. We want to know the position at time 4. So from 0 to 4, integrate velocity gives you position, because the antiderivative of velocity is position. Add on the starting position, and that gives you the new position of the object. The other part of that question says, what is the total distance traveled? Total distance traveled. The total distance traveled of an object, you are not going to, do not include the starting position. Total distance traveled is just the integral. From the starting time, this says let's say t sub 1 to t sub 2. So the starting time to the ending time. This number always has to be smaller than this number. Yeah, this number always has to be smaller than this number, just for a total distance traveled problem. Then you're going to integrate the absolute value of velocity, dt. That's how you do a total distance traveled. Big difference here. You got to integrate the absolute value of velocity. In your calculator, the way you get an absolute value symbol is you press the math button and confirm here. I believe it's math, and then you got to move over to num. You hit the math button, and then you arrow over. You got to hit the right arrow button right here, the right arrow button, to go over to num. And then option 1 says abs. And when you hit math, then move over to num, and then hit option 1 abs, it will make those absolute value symbols, and it'll give you a little box in here. And in that box, you'll put in the velocity function. So then you're going to integrate the absolute value of velocity from time 1 to time 2, press enter. And don't forget to get a definite integral, it's math 9. Math 9. So if I hit the math button and then the 9 button, it gives me the definite integral. Okay, so that's total distance traveled. So we've covered so far net change, change in position, total distance traveled, area of a region, how to use a graph with area amounts given to you, and average value. We may only have one thing left. Actually, I think that's it. There is one more thing, and that is u-substitution. I'm pretty sure, I believe there's a video on u-substitution. I'll make sure, but as far as I know, that's everything that you need to know. I mean, now I'm not saying there's not a lot of them. You got to keep working through this whole thing. There are a lot of problems. I did that on purpose so that you would get plenty of practice, okay? And the test on this covers the same content, okay? All right, let me know if you have any questions. That pretty much covers it.